Okay, so this is part 2 of the transform juicer video, and I've just made a ship player here. This is an extremely stripped down version of the player without any of the transform juicers. If I just press play, you'll see this cube, which is essentially standing in as what would be the weapon the player would have. Just to give some overview as well, there won't be any arm animations in this. I'm focused primarily on the transform juicer. So yeah, let's crack on with it then. So I'm not going to be writing this thing from scratch, but I will be going over how you set up the transform juicer in the player's scene. So let's go ahead and do that then. So first of all, we have player arms here. This is the main thing we want to animate. If we go ahead and play this scene here, this is just my default testing scene. The arms are what's actually animated. You'll see the arms are actually disconnected from the player's body, and that's what applies the movement animations. So if I was to come in here, walk about, you'll see the arms. This might give you a bit of motion sickness, but the wobbling back and forth, these are the ones that are dealing with the movement juice, the transform juicer. So yeah, so you understand that's what we're going for. We're trying to get the arms, or the transform that's the arms are connected to move about. So if we go into the ship player here, I'm going to go ahead and first of all add a transform juicer. So for me, I can just press here and do transform juicer, add him there, and already you ought to make it a child of the thing you want to animate. And let's go into the transform juicer then. So there's a fair few things going on here, but I'll try and break it down best I can. Feel free to pause anytime to go over this if you want. Now, before I go too in depth, I thought I just want to break down the transform juicer and a transform juice adder. In this diagram here, we have the transform juicer and the transform juice adder. This is how the workflow looks, and this is probably going to be enough for you to figure it out yourself, but I'm still going to go through everything, so let's go through it. Every frame on the transform juicer, we're going to go ahead and zero the rotation and the position. So we're going to zero the rotation and the position here. The next step is to iterate through all our juice adders. Bit of safety here. Make sure in the array it actually exists, and make sure it's active. And we're going to call this tick method on the transform juice adder. I'll go for that in a second, but for now don't worry about it. So we've come down. We're going to call the tick method on the juice adders, which brings us over to here. So we come down here. This is going to do its own checks on its own parameters it's given, and then that's going to update its own local rotation and its own local position of way around. Yeah. And then the result of that is going to be called from here. We're going to get the local position, the local rotation that the own juice adder has updated itself. All we've done is told it to tick itself, and then it's going to update a value, and at which we're going to read it. Then we're going to add them all together. So the position is going to equal all, we're going to append on every single position, which is going to give us the target position, and the rotation, which is going to give us the target rotation. And then finally, we'll add them all together down here. So you can see this little workflow down here, do its thing, come over here, get the value from there, and then that'll give us our final position. So in a sense, that's the architecture of this. I'm going to first of all break down the base position offset. So you'll see here, I have a base position offset. This node is responsible for, in the section where we zero off the position, we might not necessarily want it to be zeroed off to vector 3.0. So what we have here is the ability to set zeroed off at. So in this scenario, it's going to be 0.555 and minus 0.3. This is the only node with a special exception in here where we are explicitly checking to make sure we have one. You'll see here in the ready function where we collect all the juice adders, basically just all the children, which is going to make sure they're transform juice adder, and then we're going to add them to our juice adder list up here. But if it is a base position offset, we want to assign that, because yet again, when we're zeroing it, we want to make sure we're going off this if we have it. Otherwise, it will always just snap back to zero. No. If we wanted the weapons to be slightly moved off to the right, it would always center itself here. So the rotations would be skew with. So that's the base position offset. Let's quickly look into the base position offset, because this is a bit of a special case. you'll notice it's marked as a tool, as is transform juicer, but it's mainly only marked as a tool for this one node. Here we have the tick method. It's not doing anything because we're ticking it here. It's not doing anything. This doesn't do anything when you're actually playing the game. This is mainly used as a tool to set up where the original position will be for all the other calculations to be based upon. See, so it's process method here. In short, all this is doing is letting you in editor change this value here, see it update in engine, and then we're storing this override position. And the override position is once again, it's actually gotten from this method here. So target position, base position offset, get position offset. We go have a look at that. It's just going to return override position. So that's the base position offset. Okay, let's do a slightly more interesting one here. We want to add idle bob. So I'm going to go ahead and add idle bob. Idle bob, there you go. Let's go have a look at it. First of all, let's just see if it's working. So you can see the cube. It's not very obvious, but if we use the base position offset, we can probably move that into a better location. So let's go to our camera, set that up, and our base position offset. Let's just move it into a more comfortable place. I don't know. Let's try there. So if I just press play now. There we go. So you can see it's breathing up and down. So I'm going to go ahead and slightly exaggerate the idle bob. I'm going to make it, let's just set it like something silly like 20. All right. So here we have it bobbing up and down. But if I walk, it stops bobbing up and down. Why is that happening? So let's go have a look at idle bob. So in here, the first frame when it's ticked, we're going to set it to 0. This is just something I do as standard. I like a clean slate to then do my calculations off. And what we're doing here is we're searching for a unique node called player mover, and then we're going to get the flat velocity from it. We can actually have a go and look at player mover. This is my locomotion script. I won't be breaking this down. This was actually originally started from a Mrs.'s course I did, but then I've just taken it apart and modified it myself. But you see in here, we're getting the flat velocity, which is our player body's velocity. And then we're just going to flat it by taking out the y value. And that will give us a vector free with no consideration for up or down. So back in here, we're getting the length of that. And as long as that's less than 0.3, the bob will go up and down. It's as simple as that. We're using a bit of cosine math here with the transform juicer's base scale. The base scale is for, let's say you have a really big out of scale character or weapon. You can just set the base scale and that will just multiply everything by that. You feel free to rip that out. You don't need that. And there's some magic numbers in here. Very loosey-goosey. Yet again, this is the concepts, not how you should do this. Just how I did it. And there's the bob multiplier, which essentially just increases how up and down it's going to go. So that's how we're modifying the y value. And then what we're going to set finally is the local position, and we're going to lerp it, just so everything isn't so snappy. So, well, hang on a minute. We don't have these variables here. What's going on? Let's go ahead and look at the juice adder. So the juice adder has its own local rotation and local position references. And basically, we're just going to write to them. That's it. They just sit there. They don't do anything in the base class. They just boilerplate for the actual assignment here. And there's also a lerp speed as well, which is in here. Because they all lerp. I don't want them to look snappy. I just wanted them to like look a bit more organic and natural. So that one's idle bob. So already now you know how we are modifying an individual, like I say, concept, idle bob. We're bringing in a value. We're modifying the target position. we're assigning the local position to that of the target position. And then finally, the juice adder is going to take that local position, add it to the target position, and then it'll set the transform juicer to that. And so that is the system through and through. If you can understand that, you know the system, you know how easily extensible and how easily modifiable it is. So we could add move bob. So now we play move bob here. So when I walk around, wobbling side to side, I can give you a quick overview of how this one works. So in here I'm setting the modifier, so that's like how much I'm going to affect it on the x-axis, how much I'm going to affect it on the y-axis, the base speed multiplier. So same again, we're going to pull the value from the unique node, which is character mover, which you can see down here in the tree. Target direction by velocity, don't worry about that. We just want to worry about our actual, if we can get into here. And if we can, we're going to modify the target position, which yet again I zero off here. And then we're going to lerp at the end here. It's as simple as that. Each and every single one of the nodes are very independent. They don't really reference anything else. They just get fed in a value, or they go search for it, I suppose. And then they just report back to the transform juicer. That's all it is. So if we can then, if you do enough of these, which I can break them down further. I didn't want to tell you how word for word to achieve this. I wanted to give you the concept of it so you can implement it in your own game. But if I add in the player now, wrong node, player, if I add in the player, we just press play. Here we go. We just pick up a gun. You see, like all this added together really does make it feel quite nice. And something else you can do with juice adders is this here. This is a new system I've got going where it takes into account the wall and it moves the gun out the way of it. It's a bit snappy, but it works for what it is. But yeah, there you go. That's the transform juicer summed up. It was going to be 3 videos. It's only 2 videos. It's as simple as that, really. If there's any other questions you have, or you want anything, if I missed something, or you want more information on something, let me know. I can do a follow-up video. But that is the transform juice adder. Thanks for watching. Take care.